Hello and welcome to another math video. Today we're going to be taking a look at our practice test for 6.5 through 6.8, beginning with solving some equations. And we do want to consider whether or not we have extraneous solutions. So that's something we can keep in mind. Of course, solving equations is always a good idea to check your answers whether or not extraneous solutions are possible. First thing we want to do here is subtract 3 from both sides of the equation. That'll give us 4 times that cube root of y plus 2 squared. That'll equal 16. And that works out well because the next thing we'll do is divide both sides by 4. So now we just get that cube root of y plus 2 squared equals 4. Now, you can decide whether you want to square root both sides first or cube both sides first. In this case, it's simple enough to just go ahead and cube both sides. Works out well enough. That leaves us with y plus 2 squared equals 64. Sometimes if the number ends up being very large, I'd rather square root first, but this works out just fine. Now remember, when we square root both sides, we have to include the fact that we get plus and minus. So that's a squaring. Plus or minus the square root of 64. And so we end up with y plus 2 equals positive and negative 8. So really we subtract 2 from both sides of the equation. Now, of course, if we subtract 2 from a positive 8, 8 minus 2 is 6. But negative 8 minus 2 would be negative 10. Now, in this equation, extraneous solutions actually aren't even possible, but of course it doesn't hurt to plug those back in and make sure that works. Whether you do the 6 or the negative 10, 6 plus 2 is 8, negative 10 plus 2 is negative 8, but you square either of those, you get 64, so we get a cube root of 64 here. Cube root of 64 is 4. 4 times 4 is 16, plus 3, we get 19. So both answers do check out. Now when we have an equation like this one, we've got the radical isolated, so we would go ahead and square both sides. Now, again, I can't emphasize enough how important it is to make sure that we square the right side correctly. Remember, that's the same as multiplying x minus 4 by x minus 4. So whether you box it or FOIL it or use the special pattern, but we do get an x squared because we square the first term. Then we take the product of the two, which would be 4x, and we double that, so minus 8x. And then we square the last term. We get plus 16. Now this does turn out to be quadratic, so we would subtract x and 2 from both sides because we want to get everything to the same side. We get 0 equals x squared minus 9x plus 14. Looking how to factor this one, we know it has to be just plain x's, and the two numbers have to have a product of 14 and a sum of negative 9, both of which would be negative. So really we're looking at the negative 2 and negative 7. And so, of course, the zero product property tells us then that x equals 2 and x equals 7. Now, when we square both sides, that's where we have to consider the possibility of extraneous solutions. And in this case, we do get an extraneous solution there. Again, what I tend to look at is x minus 4 is negative if x is 2. So x equals 2 is extraneous. The 7 works just fine. And again, you could just plug those in and see if they work. You'll come to the same conclusion. But again, what I look at is x minus 4 is negative if x is less than 4. 2 is less than 4, so 2 is extraneous. Same sort of thing, we'll square both sides here. We'll get x squared on the left and x plus 72 on the right. It is quadratic, so we would subtract the x and the 72 from both sides. We get 0 on the right, so we're looking at factoring this, very similar to what we had in the previous one. We know it has to be x because it's plain x squared. A lot of factors for 72. Again, doesn't hurt to list out the different options that we have, although it's kind of an extensive list. Yeah, I didn't even give myself enough room to finish that. Now, of course, we're looking for the two numbers that have a difference of 1. 7 doesn't work, but 8 does, so 8 and 9. And one of those being negative, the larger of the two, so it's actually plus 8 minus 9. You probably knew that a long time ago, but again, if it's a little different or tougher combination, it's good to list that out. And so, of course, our zero product property tells us that x is negative 8 or x is 9. Again, early on when we squared both sides, we did square just a plain x. So x is negative if x is negative, so negative 8 is an extraneous solution. The 9 works just fine. Moving on to number 4 here. Now we've got the two radicals, so we want to isolate one of them. We do that by adding that square root of x to both sides. And then we would go ahead and square both sides of that equation. The left side is simple, just x plus 9. The right side can be a bit tricky, especially with that square root of x there. I like to use the pattern. So you do square the first term, you do square the last term, and in this case it works best to do those right away. But then you also find the product of the two terms, which would just be the square root of x, but then you double that, so we get 2 square roots of x. From here we would subtract the x and the 1, because we're trying to isolate that 2 square roots of x. We get 8 equals 2 square roots of x. We divide by as much as we can without creating fractions there, so it works out nicely. Here we get 4 equals the square root of x. And then we would square both sides. Of course, squaring the 4 gives us 16, so we get 16 equals x. Again, extraneous solutions would be something we'd have to worry about because we squared both sides twice. However, if you look at what we squared, square root of x plus 9 can't be negative, square root of x plus 1 can't be negative, and 4 and the square root of x can't be negative. So it's actually, even though we squared both sides twice, there's never actually a time where we could have introduced an extraneous solution. Again, it still doesn't hurt to plug the 16 in and make sure it works, though. The 1/2 power is the same as the square root. Really, we would just go ahead and square both sides of that equation. Marker over that with a little purple. 10 minus x is a little different just because of the way that that's written. Again, we're much more used to something like an x minus 10. So we would square the 10, we get 100. We would square the negative x really and get a positive x squared. And then we would take the product of those two, get negative 10x, but then double that, we get minus 20x. It is quadratic, so we would subtract the x and the 2 to get everything on the same side. And so we get 0 equals x squared minus 21x. Oops, forgot my plus sign. Plus 98. So looking at factoring something like this, again, you could list out those factors for 98. Actually, it's a pretty short list of factors for 98. So 1 and 98, of course, not going to be helpful. 2 and 49. And let's see, 14 or 7 and 14. Now, of course, it's the 7 and 14 combination that's going to work out for us. We get x equals 7, x equals 14, of course, from the zero product property. Now, a little bit different here with the 10 minus x for checking for extraneous solutions. So 10 minus 7 is still positive, so that's fine. But 10 minus 14 is negative, so 14 is extraneous. So a little bit different there with the 10 minus x. Still same basic idea. As long as 10 minus x is positive, we're okay. Here we've got the 3/2 power, but we would start by adding 5 to both sides of the equation. So we get 4x to the 3/2 power equals 108. And then we would divide by 4. We get x to the 3/2 power equals 28. Now, again, if you want to, you can change this to the square root of x cubed. oops, sorry, not 28, that's 27. Something wasn't quite right there. Okay, so 27. I was thinking of the 108, of course. Okay, so 27. Now, so square root of x cubed. Again, I would cube root both sides first in order to get rid of the third power here. So again, it's a cube root of both sides. That's going to make that smaller. So we get the square root of x equals 3. We square both sides, we get x equals 9. Again, you can plug the 9 in to make sure that that works. Doesn't take too much to figure out that it does. And we never took both sides to an even, we did square both sides right here, but we never squared anything that could have been negative, so we can't have introduced an extraneous solution there, but it doesn't hurt to check anyhow. All right, so here we've got an f of x and a g of x, and we're going to do some different operations. Again, f of x right here, it's x minus 2. G of x is x squared minus 3x. So we're doing 2g of x. That's literally just doubling g of x. So that's going to end up being 2x squared minus 6x. And again, that's just from doubling g of x here. So 2x squared minus 6x. We're going to add to that, oops, get my marker back, add to that the f of x, which is x minus 2. You can put parentheses around those just to emphasize, here's 2g of x, here's f of x, however you want to do that. Highest degree term we have is the 2x squared. We don't have any others that match that. Next, we've got our x's, a minus 6x and a plus 1x, so that's a minus 5x, and then minus the 2. So that's what 2g of x plus f of x is. Again, it's not an equation, it's nothing we need to solve or anything. That's just 2g of x plus f of x. Next, we're looking at f of x times g of x. So I would set up a box for that, especially since it's I guess this is just a 2 by 2. You could FOIL it then, if you wanted. So we got an x minus 2, x squared minus 3x. And so we get an x cubed minus 3x squared minus 2x squared and a 6x. Starting with the highest degree term we have, that's an x cubed minus 5x squared plus 6x for that. And it does want us to find the domains. These two functions do not have any domain restrictions. Again, f of x and g of x don't have a variable in the denominator. They do not have a variable inside of an even root. So no restrictions on those domains, and then when we add them or multiply them, we don't create any new restrictions. So domain for both of these is all real numbers. So same thing here. And again, we don't have anything to solve here. It's not an equation. It's just that's what f of x times g of x is. Now we've got g of x and h of x. Find the value of the expressions. They're not asking about domains here. Notice they throw the inverse of g in here. So I would go ahead and find out what the inverse of g is first. So that would be like an x equals 4y plus 1. Subtract the 1, divide by 4. So inverse of g of x equals x minus 1 over 4. And I'd probably just leave it like that for now. They want us to find h of g inverse of 5. Well, g inverse of 5, if we replace the x with a 5 here, 5 minus 1 over 4 would be 4 over 4. So g inverse of 5 is 1. So this would be the same as h of 1. H of 1, we would do 1 squared minus 2. So we get 1 minus 2, so we get negative 1. So that's what h of g inverse of 5 turns out to be, negative 1. Looks kind of like a frowny face, actually, now that I look at that again. Next, we're finding g of h of a. So really first thing I need to do is I need to find h of a, which would just be a squared minus 2, really nothing to do there. So then we're finding g of a squared minus 2, whoops, I said 2 and I wrote 3, a squared minus 2. So we just replace the x with a squared minus 2. So we would have 4, and then a squared minus 2 plus 1. So that's a 4a squared minus 8 plus 1. We combine the minus 8 and the plus 1, and we get, we get 4a squared minus 7. So that's all we've got there. And again, they don't ask about domains or anything. Okay, so next one, I have to zoom out a little bit here. So we got number 11, grocery stores offering 20% discount off a $4.50 box of fruit snacks. You also have a $2 coupon for the same box of fruit snacks. Use a composite function, show whether it is better to use the coupon before or after the store discount. So we'll need two functions. Let's, I'm just going to say have the discount be f of x and the coupon be g of x. I don't really feel like using d of x for the discount and c of x for the coupon, but you could. So definition, sorry about that. So f of x is actually going to equal 0.8x. It's a 20% discount, meaning you pay 80% of the cost. G of x will equal x minus 2. So really we would compose both of those together. We would do f of g of x, and we would do g of f of x. So with those, again, f of g of x, we'd be doing f of, what was it, x minus 2. So we would do 0.8 times x minus 2, and so we get 0.8x minus 160, whoops, marker. And the 1.6 is just 0.8 times 2. And doing g of f of x would be like doing g of 0.8x. And so we get 0.8x minus 2. So you can see between the two, you'd rather have 0.8x minus 2 than 0.8x minus 1.6. The fact that it costs $4.50 doesn't really make a difference. If you wanted to use the $4.50 instead of x, I suppose you could, but it should be clear enough using the x for those. Let me finish these two, and I think that'll be the end for this video. So find the inverse of the function and determine whether the inverse is a function. So again, we switch the f of x to a y, and if you want to just do that mentally, that's fine. But then we switch the x and the y, and then we solve for y. So we would subtract the 1 from both sides, square root both sides, which will give us plus or minus, which is why the inverse is not a function here. And then we would subtract the 3, and I'm going to go ahead and flip it around. Plus or minus the square root of x minus 1 minus the 3. So that's what the inverse looks like. If you wanted to, instead of y, you could call it f inverse. Well, actually, sorry, we shouldn't call it f inverse of x because it's not a function. So I'll just leave it as y. And then, yeah, no, it's not a function, something like that. The next one, we got f of x equals the square root of 2x plus 1. So again, this is really the y. And then we switch the x and the y. And again, if you want to jump right to here, that's fine. In order to get started with this one, we would square both sides. So we get x squared equals 2y plus 1. And again, when we square both sides, we don't have to do plus minus, just when we square root both sides. So we'd subtract the 1, and then divide by 2, and again, I'll flip it around, y equals x squared minus 1 over 2. And since this inverse is a function, we could write it in function notation, although you don't have to. And x squared minus 1 over 2 is fine. You could also go 1/2 x squared minus 1/2 if you prefer, and then yes, that is a function. All right, well, thank you for watching, and hopefully you found this one helpful, and I'll try getting up the rest of that practice test a little bit later.